Hi guys, welcome to another video and another question. So this time I have a question again from maxima minima, and this time it is well specified. We have to find the number of local minimas or maximas. So let fx be modulus x square minus 25 for all x belonging to R. The total number of points of R at which f attains local min or max is. So we have to find out the total number of points where we can get minima, maxima, which requires an analysis of this function given to us. Okay. So is it 1, 2, 3, 4? Well, it is a modulus function. With the help of this question, I would just like to, framework or work with you on a modulus case, basically. This function will be equal to what happens when you have modulus x. If you've done my previous videos, I've explained this thing thoroughly. Quick review: when the input is positive x as it is comes out. When the input is negative, minus x comes out, so that the absolute value is always positive, right? So absolute value x square minus 25 will give you x square minus 25 when x square minus 25 is greater than or equal to 0. Though I will specifically take the case of equal to 0 separately. So let me. And it would be minus of x square minus 25 in case x square minus 25 is less than 0. And what will happen when actually it is equal to 0? Then of course x square minus 25 is equal to 0, but I'm going to write it down separately. So let me just, by the definition of modulus, this is what we have. Okay. So let's take the two cases. So we've got two cases in here. One case is for the domain, from domain point of view. One case is that x square minus 25 would be greater than 0, or x square minus 25 could be less than 0, equal to 0 case. I'll write it down separately. So this means that when will this happen? When will x square will be, x square minus 25 will be greater than 0 when x square is greater than 25. And when does this happen? This happens when x is either lesser than minus 5 or greater than 5. Okay, separately, x, of course, this is just for you to understand the inequalities. Okay, that it's greater, so it is just greater, x is minus root of 25 and plus root of 25. It's related to that. How is it related? X has to be either lesser than minus 5 or more than 5. And then this is happening. And this interval, what will this give us? Inequality. X square minus 25 less than 0. This will happen when x square is less than 25, which means x is in between minus 5 and 5. So essentially, the function breaks down to three things. The third one is that x square minus 25 actually turns out to be 0. If x square minus 25 is 0, then your function will be 0. But when is this happening? When x square is 25. When is that happening? When x is plus or minus 5. Okay. So what we are essentially saying here is that fx behaves like x square minus 25 when x is either lesser than minus 5 or more than 5. It is 0 when x is minus 5 and 5. This is either, of course, at the same time, x cannot be lesser than minus 5 and more than 5. So this, of course, is either or. And it's minus of x square minus 25 when x is between minus 5 and 5. That's how you can, get your domain basically, and what is the functional value that turns out to be in whichever domain. Okay. Now, in this particular domain, see, this function is not differentiable in the entire domain, if we say. So this function is not differentiable at the points where some change is occurring, that is 5 and minus 5. Okay, I'm not getting into the details of that. I've done that in my previous basic lecture, differentiating a modulus function. So these are the main points here, minus 5 and 5, where it will not be differentiable. But in the other domain, we have a distributed domain out here. So in the subdomains, it is differentiable, and the derivative is 2x when x is less than minus 5 or more than 5. It is not differentiable at 5 minus 5, so I'm not going to write anything there. And it's minus 2x when x is between minus 5 and 5. Okay. So this is the way the derivative will flow. And hence what I want to evaluate is, mind you, this is f dash x, not fx, f dash x. So let's evaluate the sign of f dash x in these domains. So we have, say, 0 here, minus 5 here, and 5 here. So when x is lesser than minus 5, minus 5, what will f dash x look like? Well, when x is less than minus 5, the derivative is 2x. So when you will put any value which is lesser than minus 5, it's a negative value. Hence, you will get negative f dash x. If you look at on the right of minus 5, that is any value greater than minus 5 falls here. So when you will be putting even a negative value in between minus 5 to 0, you will get a positive f dash x. In between 0 to 5, your derivative is minus 2x. So the sign of f dash will be negative. When x is more than 5, your derivative is this time 2x. So the sign will be of f dash will be positive. So this means that f is decreasing up to minus 5. It is increasing up to 0. It is decreasing up to 5. And it is increasing. F is, mind you, I've written clearly, f is decreasing, then increasing, then decreasing, then increasing. That's what it is. That's what is happening. So in that case, what's going to happen? Now, I would like you guys to pause and create a graph for this, okay? Well, if you're graphing this function, 2-3 more important things that you can keep in mind. If you really want to create a proper graph, you would want to probably know about the curvature. So for that, you can find out f double dash. F double dash gives you the curvature. F double dash will be 2 when x is less than minus 4 or more than 5, minus 5 and more than 5. It will be minus 2 when x is between minus 5 and 5. So here that means it's convex, and here it is concave. So you get to know that it is convex and decreasing, then it is concave and increasing, then it is convex again, and then it is concave and decreasing. No, yeah, it is 0 to 5. It would be concave. Yes, concave and decreasing, and it is convex and increasing. So the shape would be concave, convex accordingly. Okay. Apart from that, what you would like to know It's about the zeros as in, we know that f of -5 is 0 and f of 5 is also 0. That we know. So we know that the functional value will be 0 at these points. Apart from that, what happens when x is 0? That's also an important thing because that gives us the y-intercept. So when x is equal to 0, mod x square minus 25 is equal to 25. Big number. So it's going to be 25. So what is happening is that your function is decreasing and convex like this. Not a straight line. It's just a bit of curvature like this. Okay. And then it is concave and increasing like this maybe. And say it is meeting here at 25. Y is 25. Then again it is concave and decreasing. So decreasing concave is like this, meets intersects here at 0 because y is 0 at 5, and then it is convex and increasing again. So it's convex and increasing again, which would be something of this sort. Something of this sort. So there would be a curvature attached. Of course, I'm not using any software to create this graph, or not even a graph sheet for that. But this is the evaluation. Now, with this evaluation, with this graph, you could have probably not, without doing all this, probably using your mental maths. Also, you could have done this much, but I just wanted to explain things to you guys. Now, here we are talking about local min-max. Okay, so there are certain changes happening in the function. As you can see, there is a change that happens here. There is a change that happens here. Okay, and there is another change locally happening out here. So these two values are your min values, local min values. This value is your local max value. The question has specified local, so we are telling the total number of local minimas and maximas here. There are 3 in total. So 3 would be the correct answer. That is option C. Option C is the correct answer. Now, in case the question would have specified about global min max, then global min is definitely at -5 and 5, because the least value of an absolute function has to be 0. And you're retaining that at -5, 5. But it doesn't have any maximum value. Look at the function. It's modulus of x square minus 25. So as x goes to, and it's in the entire domain R, okay? The domain is as such R. So as x goes to plus infinity or minus infinity, the function will also take the value infinity. So there is no global max, but there is a global min at 2 points. Always remember, your global min and max values are unique. Points could be multiple. Thank you. I hope this helps.